Hello and welcome to episode 25 of TGIK. Hold on, I got the sweet title card here I want to pull up. Hello and welcome to episode 45 of TGIK. How's everybody doing this week? I just got done hacking on Calico a little bit and just jumped into the studio last minute, so we're getting set up here. Thankfully, we have George here with us, who's helping us get some stuff set up, and we're trying out some new tools and some new goodies for everyone. So this is genuinely my favorite part of the week, is telling everybody hi and going through the chat. So let's go and let's see who's all here and play catch up, because I haven't looked at the chat yet, and it looks like folks have already been chatting away. So let me just load this into memory real quick, and so I'm on the same page as everyone else. Okay, so Sean says, happy Friday from Seattle. Sean, happy Friday to you as well. It's a great day in Seattle. It was raining this morning, and I couldn't have been happier. Got a great night's sleep with my window open. Lamatti, it's always great to see you. Happy Friday to you, Lamatti. It looks like Sean and Lamatti are talking. They're talking about KubeCon CFP. I thought they were talking about the TGIK notification. Okay, and then looks like Heptio, which this is George, who's joining us live from his basement studio. He says, hi everyone, this is George. I'll be helping Kris today. Everything is set and good to go. We've got good sound and audio, and we'll be tracking nodes here today. So let's pull this up real quick. So I want to go to screen and face, and let's pull up this link that George just opened for us. So this is something that he's been talking about doing for a while, and I think I've never played with this. So actually we're going to do a little bit of live playing with HackMD here at the beginning of the episode. But I talked with George about it, and he said this is something that we can totally come in and folks can contribute real time here. So how would I do this? Do I do editable? Signed in and people can edit. Do I just start typing? How does this thing work? Like, what if I wanted to change this? Okay, that's not working. There's got to be like an edit button or something. 14, oh, right here. Okay, so that's what's going on, is up here at the top left, it looks like there's view, there's both, and then there's edit. So, oh, cool. So then I get like this like hacker style theme where I can come in, so I can then come in and say, hacks for the episode. Here, we'll do a quick comment here. Oh, I want to log in. I'll sign in via GitHub. Authorize HackMD. So I think you guys can do this too at home, and you can actually contribute to the notes or ask questions here. And then let's go back here. Okay, we're still editing. So let's go back to our /proc, and then I can now come in and say, look at our C groups in /proc. And I bet I can commit this somehow. I don't know how to like save or commit or whatever. Can I just do both? Oh, okay, cool. So it's like real time. Sweet. Okay, cool. So it's like real time editing, and then other folks can come in and edit as well, and then George can PR this afterwards. Okay, so this is me learning how to use HackMD for the first time. This is a sweet tool, and thanks for setting this up, George. So what we're editing is this file, which is our weekly TGIK episode 45 file. And this week we have a picture of a kitty, because Calico. I wish this was a cat that I knew, and I thought afterwards how I totally could have used a picture of my partner's cats, but I just picked a random kitty anyway. So hopefully we'll do some of the other Tigera tools so I can actually use real kitty pictures. But anyway, we have the Calico picture there. Let's see what folks have been saying in chat. Dum dum dum. So Arnan says, hi folks. Adele, good to see you. Sarush, greetings from Hamburg. This is my favorite part. Rory, evening. Elisiano says episode 25. Do we have episode 25 somewhere? Maybe there is a typo on my end. Keith, hello from Scotland. Ed, hi from Starbucks. Good to see you, Ed. I love Starbucks. I really do. I like pumpkin spice lattes. Let's see. Greetings from North Carolina. Hello from London. Hey, Saeed. Zult, hello from Finland. Montreal. Toronto. Tim Carr. Timmy, good to see you. Simon, greetings for Bordeaux. Justin, welcome back. Jesse, wave, good to see you. Australia, there's a lot of folks today. Alex says hello from San Francisco. Happy Friday. Alex, good to see you. And thanks for all your help this week, Alex. And I can't wait to make it back down to San Francisco so I can hang out with you folks at the TGI office and see how you guys have been doing. Let's see here. We have hello from Bonn. We have hello from Portland, Germany. Let's see, howdy from Vegas. And I think folks are trying to help me with HackMD there. And then another person, Duncan from San Francisco, Carl from New Zealand, Leonardo hi from Brazil, San Diego, and Turkey. Okay, so a lot of folks joining this week. And that's really exciting. So I've been talking with a handful of people in the Kubernetes space, and a common theme over the past, probably 30 to 60 days, here, I think my camera's a little crooked, a real common theme over the past 30 or 60 days has been folks kind of like wondering about CNI and wondering about which one they should use, and are there's like metrics on them, and if people have like good ideas on which ones to use, or more importantly, like why do we need them and what does it even do? So after getting a lot of these same questions from folks in the field, I thought this would be a really great way for us to go and start off like my first little mini-series here in TGIK, where we talk about CNI in depth, we talk about how CNI came to be, we talk about where it is today and maybe even what it might look like tomorrow, and then we can talk about different CNI plugin implementations over the next couple of TGIK episodes that I'm going to be doing. And the first one, of course, my personal favorite so far, but I might have to pick another favorite at the end. I don't know, because I haven't played with really any other ones as much as I played with Calico, but we're going to be doing Calico today. And if you look at the Kubicorn bootstrap scripts, this is like a good little like trip down memory lane here. When we released Kubicorn at GopherCon a year ago, I remember we ran into a problem that we're actually going to replicate today. That's how we're going to learn about Calico, is to actually replicate this problem when we first released Kubicorn, which was we couldn't actually schedule any pods on our nodes. And I remember Kelsey was there, and he swung by our table, and he said, oh, I just solved this in something else I was doing, and he gave us this little one-liner here. And a year later, the one-liner is still there, and if you look, it just does the Calico install. So this is totally where we're going to start hacking into Calico once we get there a little bit later in the episode. And we're going to be using Kubicorn to set up a cluster that has this line commented out. And then we're going to talk about everything that's happening in the cluster, why the cluster is broken, and then actually look at Calico coming to life and sort of fixing the errors we're seeing in our cluster and seeing how it's mutating the host underneath. Oh, wow, we have even more people. So it looks like folks are excited about learning about Calico and learning about CNI. I know I certainly am. We've gotten great feedback this week, so hopefully we can do a couple of really solid CNI episodes here and really go deep into sort of the technical networking stuff in Kubernetes and understanding how it works and why we need it and how it's doing what it's doing. So more folks here. We have Mark from California. We have Sanket from Naperville, Boston, Bosnia, Minnesota, Germany. I think this is our first London. Hi, Nader. Good to see you. I think this is our first India. Oh, and Mark says it's International Beer Day. Well, why am I drinking Diet Coke if it's International Beer Day? I wish there was somebody else here at the office who could totally bring me a beer for TGIK, but we'll see if we get lucky enough. Okay, so let's go look at our document here and see what's been going on in Kubernetes this week. So I put together a long list of commands that we can use as we're debugging Calico and as we're looking at the Kubernetes system, and a lot of these commands give us some visibility in what the host is doing behind the scenes. And then down here at the very bottom, we totally have some reference links. More people, hi from Colombia and hi from Turkey. Good to see everyone. So the first one we have here is our shared notepad, which is the HackMD that folks just watched me figure out how to use. The next one here is the Kubernetes CNI plugin documentation. So if we come here, and actually I think George, let me just check really quick. I think George might have added other links here, maybe not. Okay, but oh yeah, here they are. So we're gonna go through all these here in a second, but I wanna call out this one first. This, if you wanna start reading and looking at some of this as we go through the what's new in Kubernetes this week, this is a good place to start, and this is gonna start to at least let you as a person think about what CNI sort of does behind the scenes and how we're going to interface with it. But if you want to check this out, we're going to go through it in depth later, but this is a good starting point if you want to pull that up on another tab next to my beautiful, handsome face. That's a good idea. Okay, so here, let's see what our week in review is. So it says Linux Foundation is having a sale on Kubernetes training. It's a sysadmin day sale. Oh, that's pretty cool. So it looks like we're cutting prices at the Linux Foundation. Come on down. Looks like we're getting some systems administration bundles for like less than half off. They have an engineer program, it looks like, something for OpenStack and Kubernetes admin. So this one's cool. I've heard some good things about this, and I know we have the Kubernetes exams that you can get, the CKA exam, and there's Kubernetes fundamentals. This is a great program. I've heard folks who have taken it. They've gotten great jobs after the fact. They know more about Kubernetes, and they really increase their value as an engineer and as a systems administrator. So that's a great program there. Let's see. Sebastian Gascoigne talks about Knative build primitives. So Joe and I have this like running banter that we're both usually pretty busy on the Fridays. We don't do TGIK. So it's actually pretty hard for us to watch the other one's TGIK because that's like our Friday to kind of catch up. So I only was able to catch a few minutes of Joe's last week, but everybody I've talked to has been freaking out about how great it was and how much they enjoyed it. So I still need to brush up on my Knative as well. So I definitely need to watch Joe's TGIK so I can speak intelligently about this new tool that came out of Google. But yeah, it looks like there's this whole blog here that talks about the build primitives and getting it set up, and it looks like it's building it from source. And it looks like it kind of goes through Knative, probably in a similar fashion that Joe did. So this is a good step and a good resource if you want to go and explore Knative more on your own. And then, of course, our friend Sebastian always writes wonderful technical pieces. So I'm already pretty excited about this just because I've read some of his other stuff, and it looks really good. So coming up next, we have the KubeCon CFP closes on August 12th. I've had a lot of folks, both from TGIK and my work in upstream Kubernetes, reach out to me. I've even gone out of my way to meet with a couple of folks to talk about KubeCon CFPs. This Monday is my big CFP day, so if anybody wants to reach out to me, Monday is the day to do it. I'm setting pretty much my entire day aside to working on my CFPs. I'm happy to share my CFPs with folks, and I'm happy to look at yours, and I'm happy to help in any way I can. But Monday is definitely like the day to do that. Oh my gosh, I feel like such a salesperson. Like, Monday, come on down, Linux Foundation, half off Kubernetes certification exams. Anyway, Kubernetes 1.9.10 and 1.12 Alpha 1 are out. This is exciting because we literally just released 1.11 and we're already in 1.12 Alpha, and I have stuff I need to get out in 1.12 Alpha, and so I'm already like, gosh, the Kubernetes release cycle crept up on me again. I always say this is going to be the last time it creeps up on me, but it always seems to just be right there, right when I least expect it. Looks like we have more people in chat. Felipe says, hi from Paris, just won TGIK before holidays. Sean Smith says, interesting, I might have to invest in one more of those. Stephen Afar says, hi from Prague. Guys, we really have people from all over the world here on this live stream right now. This is so cool. Next up, we have Lockie. He checks out Kubernetes extension for Visual Studio Code. So yeah, his name is Lachlan. I've worked with him, and I call him Lockie. I think he's okay with that. He's never told me not to. But let's listen to Lockie for a second.
VS Code extension for Kubernetes, and I posted a video with that tweet, and it was from several months ago.
Okay, so this is Lockie talking about the new Kubernetes VS Code extension. So I remember seeing Ralph, another old colleague of mine from Microsoft who I keep in touch with. I saw Ralph do a live demo of this, and this was pretty mind-blowing. You were able to actually go in and edit Kubernetes YAML right there in VS Code, and it really made like navigating Kubernetes, editing Kubernetes resources, exploring Kubernetes resources a lot more user-friendly, and was a really, really cool extension. So I'll probably be checking this out later and even thinking about switching back to VS Code just because a lot of the stuff that I've been doing in Crex is already solved with tools like this. So check out Lockie. He's a great guy giving us a demo over VS Code using the Kubernetes extension. That's a great one. I think George is the one who found that link, so hats off to George. We have Qbert, extending Kubernetes with CRDs and virtualized workloads. So I saw this on Reddit, like I think last week or the week before. The thing that jumped out to me was less about Qbert and what Qbert does, although I'm sure Qbert is a great tool. But this little snippet here, why use CRDs over aggregated API server, this is an interesting read for folks who are looking at building out, a little more complicated software on top of Kubernetes. This is a big discussion we've had in the cluster API working group under SIG cluster lifecycle, where we went from CRDs back to aggregated API server, and now we're on our way back to CRDs again. So there's a lot of pros and cons to each approach, and I think having a good compare and contrast there is going to be helpful. Anyway, Qbert is a Kubernetes add-on that provides users the ability to schedule traditional virtual machine workloads side by side with container workloads. Okay, cool. So I think Joe was tweeting about this the other day, or somebody tweeted about Joe saying this at OliCon yesterday or something, which was like, virtual machines and containers now exist side by side, and it's just a matter of picking what's right for you and your team. Looks like Qbert is a totally great example of a time where you could sort of run containers and virtual machines sort of in concert with each other, depending on your use case and how you want to approach running your software. This sounds exciting for folks who are going down that moving my monolithic application to Kubernetes journey, where they may have already have their application configured to run on a certain type of virtual machine. So this is a pretty cool read if folks want to come check that out as well. Edge computing at Chick-fil-A. You guys can read that if you want. I'm not going to pull that one up. Nfs Persistent Volumes with Kubernetes. Yeah, so it's a case study here. So let's see, NFS Persistent Volumes with Kubernetes, which NFS is pretty much the common way of doing any sort of network file storage. And you can use that with PVs and PVCs. It's one of the volume types. I think Joe's done an episode or two on volumes and storage in Kubernetes. If we don't have a good TGI, we definitely should do one where we look at NFS and a couple of the other different commonly used volume types. But this looks like it's a good way for folks to go through and learn about setting up an NFS server, actually getting volumes to mount into your containers, understanding the different types of mounting, where you would want to read only, where you would want to read write, so on and so forth, and actually building a Kubernetes NFS server inside of Kubernetes. So this is a pretty cool read, and this would be really handy for folks who want to do some pretty cool things with keeping your data stored offsite, or even taking data that already exists and plugging it into an application running on Kubernetes. So this is a great read as well. Okay, so that's what's new this week in Kubernetes. Also, over the past probably 4 or 5 TGIKs that I've done, I've always made it a point to go through and do like a really quick Golang 101 for folks. And I didn't get a chance to get around to coming up with anything this week. So this is a call for questions. If anybody has anything in Go that they want to ask me, I'm happy to write some really quick code in a few minutes and just answer the question. Maybe there's some weird syntax you don't understand, or there's some pattern that doesn't make sense to you, or a question you've always wondered why it is the way it is. Feel free to ask in chat, and I will do my best to answer and help you with your Go problem. Chances are other folks have also wondered the same thing that you're wondering. So even if you think it's silly or something small, but it just doesn't make sense to you, feel free to drop it into chat, and we'll see what we can do. Okay, big deep breath. We did that in 18 minutes, which was a good intro. And I think it's time to start hacking on Calico. So let's look at what we have here. So here's my terminal, and I want to go into my Go path, Heptio, TGIK, and go into episodes. Also, can you folks tell my hand is doing way better? I'm able to type and actually navigate the Linux file system at the speed I used to. It feels so much better to be able to navigate the Linux file system quickly again. That was really hard for a while. Anyway, we go into 45, and here we have, let's do a tree. Here we have the README, which is what we were just looking at. We have a directory called Kubicorn, and in there we have a shell script called Amazon Kate Ubuntu 1604 master, and we have another directory called TJK Calico cluster, cluster.yaml. So what we're going to do is we're going to nuke the Kubicorn TGIK Calico cluster, and we're going to create a new one. Lamati says, oh, we have some Go questions in here. It looks like Steve says, difference between normal mutex and rewrite mutex. That's a good one. I don't know if we're going to have enough time to go into the whole read-write mutex and how it's different than a regular mutex. Lamati says, if no one answers, what are your thoughts on versioning? That's a good one, because I can just rant about this and it's a little more high level, so I feel like I can do this really quick. On versioning, if you remember Sam's keynote at GopherCon last year, it was sort of like a call for action for folks to begin versioning their Go programs. And I think, the Go community is just constantly in this struggle to figure out what we're doing with package management and versioning. And I feel like every 6 months there's like a new hero and a new effort. I really thought DEP was going to be the winner, but I think we're exploring other ideas right now. I contributed to DEP, so there was a fair amount of heartbreak for me when I found out that my work there. So yeah, I think versioning your Go programs are important, no matter how we're going to end up ultimately solving package management and dependency problems in Go. I think versioning and adhering to a strict semantic versioning policy for your Go program is going to be important. So no matter if you want to use DEP, if you want to use Glide, if you're going to use some new tool, if you want to use Vigo, if you're going to put it into some sort of package management, having semantic versioning helps folks, and it also really helps folks who are trying to vendor your program understand when they can expect a breaking change. In some cases, they can bump a minor version and trust that the rest of their program is going to compile. But if they bump a major version, know that there might be some API incompatibility, and then they're probably going to have to go through and rewrite some of their code that they're using internally. So I think it just sets interesting paradigms, and I think it's a good habit for folks to get into. And I think there's tools out there like there's semantic versioning packages that make it much easier and sort of enforce the semantic versioning, where if you do make a breaking change, it will detect that and then actually say, no, you need to bump this, or we're not going to let you push up there. So you can build that right into your build pipeline as well. So good question, though, Maddie. I think versioning is important, and if you're not doing it, you should do it, and you'll thank yourself later, and the rest of the Go community will thank you as well. Okay, so anyway, back to Kubicorn. I just nuked our old state store that I was using before TGIK, and we're going to do this thing on the fly. So if we go back into our episode here, this is how we're going to set up our Kubicorn cluster. So we're going to create that YAML file that we just deleted using this command. And I want to kind of show folks the command and then show you what happened here. So we said Kubicorn create TGIK Calico. This is capital S, stands for state store, so we're telling it to make it in this Kubicorn directory here. P AWS, telling it that we want to create a cluster in Amazon. And then this -m means we're going to mutate the master provider config. And we're going to say, in the server pool, we want to set the first bootstrap script at 0 index. So the first one is equal to, this is a local reference, the Kubicorn directory, and the name of our shell script, which is, of course, right here. So if we actually look at this shell script, we can see, we'll do a side-by-side, and we can see how this differs from the normal Kubicorn bootstrap scripts. So Amazon K2 Ubuntu, and I tweeted about this earlier today, it was like, oh, this program makes this way too easy to come in and just add little one-liners to make your Kubernetes cluster just special for you. So the first thing I did, I came in here, is I added Emacs 24 so that when we SSH into our master later and start looking at Calico, we'll have Emacs to explore it in. And I added this alias here, which there is you can copy and paste this out of the Markdown. This is great if you ever need to list all of the IP tables rules for every table. This is a great little handy alias, and it fits the IP tables - some subcommand syntax. So we're adding that to the end of our bash profile. And down here at the end, this is just a normal Kubernetes bootstrap script. You can see them in the Kubicorn bootstrap repo, which is linked in the README as well. You can see I have this big doc block here that says, note, we hack in here for TGIK, and then this is where we uncomment the Calico installation that normally ships with Kubicorn. And then we apply our cloud provider, and we do some weird stuff on the file system so we can get our kubeconfig later. But we're intentionally deploying a broken cluster so that we can start to explore the file system and explore Calico and see how it works and see what it's doing. Okay, let's see here. So we have a question. It says, I'm sorry, I'm not even going to try. Anyway, we have a question. It says, Kris, your thoughts on dependency management tools in general and new Vigo stuff specifically when you get a chance. So I think dependency management is just fundamentally a hard problem. And the Go programming language keeps introducing new features that actually make dependency management even harder, but it makes programming in Go much easier. Vanity package name imports is a great example there. I think I haven't really used Vigo. I just use dep, and usually 99% of the time it works for me. I'm really busy, so I actually don't get much time to actually go play with new software because it's fun. Most of the time if I'm playing with software, it's for TGIK, and otherwise it's pretty much full-time doing my work here at Heptio or getting ready to go climb a mountain. But maybe we can do a TGIK on Vigo, or maybe we can bring it up in a future episode. If you want to open up an issue in the TGIK issues tracker in GitHub, which is, of course, here, we can, you can come in here and add an issue, and we will definitely try to check it out. So, terminal. And then, of course, I don't know if Joe's used it. Maybe Joe has opinions there. Usually if Joe's used something, he has opinions that are worth listening to, usually. Okay, so let's get out of Emacs. That's our shell script there, and now we can run our kubecorn apply command. So let's come back to our README and scroll down and grab this command here and paste it into our terminal. So while we're waiting for that, we can talk about what's going on up in the cloud right now. So I think I've done an episode on kubecorn, but most folks have used it, and all we're doing is creating some infrastructure. We have a brand new VPC, we have a brand new internet gateway, and we're creating some rules and policies, and we're poking some holes in the firewall, and we're creating a route table. So this is all important to note as we actually start looking at CNI and Kubernetes and how it's going to handle the routing. For today's episode, we're deploying a relatively simple Kubernetes cluster, and we're not going to dive super deep into how Calico is working on the Amazon routes, but I definitely think there could be a follow-up episode where we really go deep on seeing how CNI works with the VPC, and maybe even looking at how different CNI providers, like the one that folks at EKS have been working on, come in and the pros and cons, and compare and contrast those different issues as we move forward. Okay, so while this is coming up, let's go back and let's look at our notes here. So here's the alias I showed you earlier if you want to grab it, and then all the alias is doing is just running these commands here as well. Oh, Dems. I didn't realize that was your full name, Dems. So yeah, anyway, no problem. I'm happy to answer that. Dems had just said he was the person who asked about the Vigo stuff. Saeed says, I wish there was no such thing as GoPath. How about you? I love GoPath. Ever since I learned GoPath, like, I was frustrated for maybe 5 minutes, and 3 or 4 years later, I still love my GoPath. But a lot of folks, I've met a lot of C programmers, met a lot of Perl programmers who all struggle with GoPath and think that it's overly prescriptive. But if you think about it, by encouraging GoPath and putting a dependency on that, the Go compiler and the way that Go works can make a lot of assumptions that would be really hard to track otherwise. I know we've all been in situations like in Python where we have like Python virtual environments, and Python behaves differently in one directory than it does in the other. And then you get into some really weird behavior that you got to kind of keep track of, and it becomes a support burden for the programming language over time. GoPath just says we can guarantee it's going to be like that, and it's going to work well. So it's like if you're okay with following the rules and you understand the rules and why they're there, I think GoPath is a great idea. I really like it. In fact, if you look at where I am right now, go source github.com/heptio, blah, 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 or I guess print working directory, I check out all of my software into GoPath just because I like the idea of knowing that all my code is neatly organized in this like sort of like source, the name of the organization I'm storing my code at, the name of the repo or the org that I belong to at that broader system, the name of this repo, a directory in the repo, a file in that directory. Like, I just like that flow, and I feel like it's a good level of balances. So anyway, we have completely deployed a broken Kubernetes cluster, and I should be able to kget nodes and see, yes, we do have 2 nodes up and running. And we're going to open up a couple tabs here, and I'm going to kind of get my command station set up. So let me grab some Diet Coke first. Okay, so I'm going to do a new tab. I'm going to zoom in here. Oop. Cancel that. I just opened up the printer for some reason. Okay, zoom in, and then let's do a resize. Cool. Looks like we have a question. Bjorn says, I'm still curious why to choose the CNI over others. Would be nice to know. Celium says to use BPF instead of IP tables to get more performance, if I understand right. What about this? So again, Bjorn, I'm just now starting off exploring the other CNI providers. I picked Calico just because I've used it before. As we move forward, I'm hoping that in the end of this series, we're going to be able to use Calico as sort of our control variable here and compare some of the other ones. And I think what Bjorn is hinting at is that, and we're going to learn this as we actually start looking at how Calico is working behind the scenes, is that there's two main concerns that Calico solves and that you'll see with other CNI-style tools, which is enforcing network policy as well as actually helping with the pod networks on the host system. And in this case, Bjorn is alluding to the fact that Calico uses IP tables as one of their deferred implementations of building and managing and mutating those pod networks. And it looks like this new tool, Celium, that I've heard a lot about but have never used, uses BPF instead as an alternative. So I think this is more of like, two ways to skin the same cat, and there's probably pros and cons to each one. And hopefully we'll learn those a little bit more as we start looking at them. I was kind of thinking about doing Celium next, just because I've been hearing a lot about it. And I want to see how it sort of compares to Calico moving forward. And Tim, thanks for joining. Tim says BPF is still nascent in Kubernetes. Great comment. Thanks, Tim. Okay, so anyway, let's look at our Kubernetes cluster, and let's go through this sort of story of like understanding why we have CNI and how it impacts our cluster and what's going on with the different levels or the different components in the kubelet on this Kubernetes cluster and see what is happening. So in order to simulate this problem, Tim Clare says, cat puns, yay. I'm glad you picked up on that. I thought it was perfect. Let's deploy a pod. So k run nginx -- image nginx. So this little command I just typed. I remember one of my old colleagues at Microsoft, Matt Tucker, said this to me like at work one day. He was like, yeah, just do a k run nginx image nginx. And I was like, what do you mean? And this is actually one of my most commonly used debugging commands to this day. I've still been using it like 2 years later. And all this does is it just runs an Nginx pod that serves as an HTTP server, and you can use it for 1,000,001 different things. So if this is not in your Kubernetes debugging repertoire, you should definitely add it now. It's a good one to have. Looks like George says, reminder, for those of us just joining us, you can help us take notes. So yeah, there's a HackMD if you want to go and log in and contribute to the notes. That's always appreciated. Okay, so let's run a pod. And it'll create a deployment with a replica set of 1, and we can go and look through all that. But we're just going to trust that deployment in Kubernetes is doing its thing, and let's just see our pod here. So we have our nginx pod, and that is in status pending, and we'll explore that a little bit more later. And let me clear the screen over here, and let's SSH into our master so we can start to kind of see things side by side. I'm hoping to kind of do like on the left side here, this is what's going on the server, and then the right side, this is like a user who's trying to interact with Kubernetes and what are they doing and what's happening on the server behind the scenes. So the first thing we want to do is we want to SSH into our master. So we'll grab this command, we'll SSH in, we'll tell it to add it to our SSH hosts, and I will just sudo up to get us started. And so I can come in here and I can go to cloud log or var log, and then I can cat out cloud init and actually see, yes, that bash script that we had on my local file system did in fact run, and that's how we bootstrapped Kubernetes. And a quick sanity check, let's make sure Emacs works, and beautiful, it does. So yeah, that was a great bootstrap script hack. Thanks, Cubicorn. Pat myself on the back there. And let's see what's going on with this pod. Chromefire says, isn't there QRD for debugging deployments? Yeah, that's the thing Joe uses all the time. I just like to use Nginx because it's just an old habit of mine, but QRD actually does a lot more. It does some cool DNS lookups, and it serves a nice dashboard and acts as a good landing page for folks. So that's a good one as well. I've actually never run it before, but I could try it out one time. Maybe one time on TGI, I'll just try to run it on the fly YOLO and just see how it works. That would be actually kind of fun. David says, krun nginx image nginx -- dry run -o YAML is cool to also get a quick YAML template for deployment. Dem says, kubeproxy switched away from IP tables and IPVS. If I remember correctly, does Calico support that too. Today we're going to be looking at kube proxy mutating IP tables rules, 100%. That's going to happen. And I don't know about Calico. I know we have some engineers from the Calico team here with us, so hopefully they can jump in and give us a little bit of guidance on questions like this. Lamati has a question for Tim. BPF XDP support also isn't available in most standard operating system releases. If you run Bleeding Edge in production, that has got to be fun. I mean, Bleeding Edge in production, this is a Kubernetes live stream, right? That was a joke. Come on. I'm killing it today, you guys. Yes, Alex says, yes, Calico supports IPVS kube proxy. Good to know. Okay, so we're here on our server in our home directory, and I want to see what's going on with this pod. So, you know, to tell a story, we're here at GopherCon. We just got Kubernetes up and running with kubeadmin. We're excited. We tried to run a pod just to see what happens, and poof, we're stuck in pending, and nobody knows what to do. And then we start to go through this, oh, we didn't install CNI. We have to figure out CNI story. But a lot of folks, I'm assuming, have gone through the same journey, and I'm going to kind of point people all the way through it of actually understanding why this pod is in status pending and how that relates to the Calico tooling and how that relates to the different various pieces of software running on our server over here. So the first thing I'm going to eat it in really quick. Sorry, I was like, I'm going to put an M&M in my mouth, and then we realized I was like sitting here talking and was like, wait a minute, I can't eat an M&M and talk at the same time. Okay, so let's describe this pod. Okay, describe, PO, bam. So if you come in here, you get some good information, and if a pod is ever in status pending, it's good to do a describe on it because clearly you're not going to be able to get logs because nothing's running. So this is usually a good starting point to at least get some visibility in what's going on with Kubernetes and why your pod isn't starting. So if we come down here at the top, we can see that, yes, it's a replica set from our deployment called Nginx. It's running the default Nginx image. And if we look, let me see if I can scoot this thing over to make it a little more legible. If we look as we scroll down, it says pod scheduled false, default token, yada, yada. There's some taints and tolerations, and it says failed scheduling. 0 of 2 nodes are available. 2 nodes were not ready. So if we come here and we do kget nodes, we'll actually confirm that 2 of our Kubernetes nodes are in status not ready. This is interesting behavior. The status on a node is important because if a node goes into status not ready, the cloud provider might do some interesting things like mutating the ELB behind the scenes or even turning that off if you have one configured. And also will try to, actually, never mind, we're not going to go into that today. So anyway, we want to get these nodes into status ready. So how can we see what's going on with these nodes? So we can do a describe on the nodes as well, which is pretty handy. So we can do kdescribe, actually let's get the name of a node. Let's do kdescribe node. This is our master node here. And we can see what's going on here. And this gives us a little bit more visibility into the actual underlying server that is running Kubernetes on top of it. So if we scroll all the way up to the top, we'll go through this thing again, kind of line by line. You can see here we have some conditions and we have some statuses here. That looks, probably that's about the best I'm going to get it. So it looks like we're having some out of disk, some memory pressure, some disk pressure. At first these can look alarming, but the one that is really kind of standing out at me is this last one here. Cubelet not ready. Runtime network not ready. Network ready equals false. Message Docker network plugin not ready. CNI config uninitialized. Okay, so what that is telling me as a systems administrator is that the Cubelet is having problems on the server because it cannot find what it needs to for CNI. So let's look at how the Cubelet is going to be looking for various CNI providers. So we do that by SSHing into our server here, and we want to check out the Kubelet logs. So this is a great command. Folks, if you haven't run this, it's actually quite rewarding because you get to say journal cuddle fu kubelet, which if the kubelet ever breaks and you're trying to debug something, that's pretty much what you would be saying anyway. Oh, journal cuddle. Journal cuddle fu kubelet. And we can actually get the kubelet logs that's running real time. So the way the kubelet works is it runs as a systemd watched service on the node. It's not running in a container. It's actually a true system service. So if you're familiar with how systemd works, you're going to be very familiar with how to debug the kubelet, which this experience is significantly different than debugging a pod or a node that we did over here in this screen a few minutes ago. So if we come through, we can enter some space here so we can get like our log message isolated, and the kubelet is just going through and stutter stepping and retrying over and over again, seeing what's going on. And it says unable to update CNI config, no networks found in etc CNI net.d. So I'm going to take this opportunity to pull up some documentation here, and we can look and see kind of why the kubelet is doing this and where we can configure the kubelet to do this in different ways, and we'll look at the docs here. But let's see, David says the other conditions were all false, out of disk, memory pressure, etc., so they're not really alerts. I always find that part to be misleading. That's exactly what I was alluding to, David, was if you look here, let's see where I can find them, where are the conditions? It tells you the different conditions it's checking for, but it says false. Right here. So if we select this, it says out of disk status false. So that's what David is referring to. So these are just checks that it does no matter what, and then it'll just give a little piece of output on it that says what is going on with that check, and if you actually look, it says kubelet has sufficient disk space and it has sufficient memory pressure available. So the kubelet is happy on those regards, and then we get down here to the bottom, and it says not ready, and we have a message on why that one's not ready. So a little more clarity there, and let's pull up this documentation so we can see what the kubelet is doing by default. It is here, I think at the bottom. Bam. So we had some folks helping me in the Tigera channel earlier. This is a great link they provided. This is the link I said at the beginning of the episode you should go check out that we were going to get to a little bit later. So if you did read it, you already are a step ahead of the game here, but we'll go through this for folks who have not. So this is the Kubernetes documentation that talks about CNI. And if you look, it says the CNI plugin is selected by passing the kubelet, the -- network plugin equals CNI, meaning we can have multiple network plugins. The CNI is just one type of network plugins that you could use in Kubernetes. And then we have CNI confter, which default is to etc CNI net.d. And then we have CNI bender, which defaults to opt CNI bin. So if we go back in our file system, we can actually see what flags are passing into the kubelet by going and checking out the unit file in the etc systemd system directory. So we go etc, what did I do here? etc systemd system, and in here you can see all our unit files that we're watching with systemd, and I just know this was here because I wrote kubecorn and I know we use kubadmin and I helped bring all this stuff to life. So this, it might look different on your file system here depending on which tool you're using to bootstrap Kubernetes. So if we actually look at what's going on in the systemd system kubelet service.d directory, we can see all of our configuration bits for the kubelet. In this case, we have two files here. We have kubadmin.conf and cloudprovider.conf. We're just going to count them both out at the same time so we can see all of the flags that we're looking for. And so here we go. We have our first service file that starts here, and we have our second one that starts here. The second one, pretty much all it says is cloud provider equals AWS, which is just enabling the Amazon cloud provider. But this first bit is broken up into different sections here, where we have kubelet config args, we have system pod args, we have network args, and that's like me as a systems administrator going, aha, I now am looking at where we're passing in network arguments to the kubelet, and sure enough, by default, we have network plugin equals CNI, CNI confter, we actually reset it to what the default already is, and we keep our CNI bender the same. We reset that to the default as well. So the hacker in me is like, okay, let's go see what's going on in the opt CNI bin directory. So earlier today I came in here, and this was created by kubadmin. I'm assuming this was created by kubadmin. Good question for kubadmin folks. Maybe Tim, could you give some color here on what actually created this on the file system for us? Anyway, we have a couple of different executables here. And of course, me being the hacker that I am, I was like, okay, let's go ahead and see what flannel is. And it's a compiled executable, and I was like, okay, let's just run it, YOLO. So I ran flannel, And I got this like CLI command in variable missing, and I got a little snippet of JSON, and I was like, okay, well that's not very fun. Let's try a different one. And I said, okay, let's run IPVLAN. I said, okay, that's not very fun. Let's try a different one, and I ran VLAN. And I went through and I ran all of these one at a time. And this is where I went, oh, I should probably tell people about CNI and why it is the way it is, and why it all of these commands are looking and feeling almost exactly the same, even though they're different. So let's pull up the CNI specification here. CNI spec container networking / CNI. So I know there's some rich history here of folks in Kubernetes networking and the Kubernetes container space about bringing this specification to life. Oh my gosh, I've contributed to this file? I really didn't. I don't even remember. I guess I've contributed to this file in the past. But anyway, I guess people came in and said, you know, we were doing things differently. The community was fragmented, and they wanted to come together and build an API. And to me, especially with the work I'm doing in the cluster API working group right now, this is very special. This is very important to me. I very much want Kubernetes installers, like Kops and Kubicorn, to look more like this and less like the giant noise that you see today, where each one is completely different. So it would be really cool having some sort of standardization there. And Tim St. Clair says it's dropped by the CNI package. So I bet if we go and we look at our shell script here, which directory we're in, let's clear that. And let's go to go source github.com, Heptio, TGIK, episodes, 045, Kubicorn. I bet if we cat this out, we can see we're installing CNI somewhere. Cloud utils, Kubernetes CNI, right here. Okay, so that's the package that actually created the binary files that we're looking at right now, which it gives us these various CNI executables here in this opt CNI bin directory. Anyway, going back to the spec. The history here being folks came together and said, okay, we would like for each of our plugins to sort of behave the same, and we're actually going to standardize an interface. And the word interface is kind of hard for a lot of people, especially the folks who are new to Go or maybe even new to Kubernetes. Interface doesn't always necessarily mean like a Go interface. It just means what is the surface, how would another component on our system interact with this other component. And in the case of CNI, we're actually, our interface, the point where the rubber meets the road, is actually just doing a shell exec of these various commands. And the way that we standardize how Kubernetes is going to do a shell exec of these commands is by enforcing the commands behave in a standardized way, meaning that you always get these same error messages in the same snippet of JSON that is incompliant with the CNI spec that we were just looking at, so that your plugin always answers and responds in the same way, regardless of if you're using Flannel or any of these other CNI plugins here, or Calico, the one we're actually going to get up and running a little bit later. So that's interesting for folks, especially because it's just like we just want all of our command line tools to behave the same, and that sort of is what makes up a CNI plugin. And then, of course, the Cubelet can count on each of those CNI plugins to behave in a way, and then we can sort of exchange data back and forth between the plugin and the Cubelet over shell exec, which is fascinating. If you're wondering, like, if the cloud is all bash, like, yes, we just shell exec things. That's how Kubernetes works. It's pretty cool. So yeah, if you want a chance to come in, you can look at the spec. It literally just goes through and talks about how you would structure your output and what your input should look like, and then gives you like some guidance on like if you want to develop your own CNI plugin, you can come through and you can like write your own program that is CNI compliant, and then you could actually configure Kubernetes to talk to your CNI plugin in the same way that we're about to configure Kubernetes to talk to Calico. So that's pretty cool. You could write a CNI plugin in Bash if you wanted to. And we'll talk a little bit more about what CNI is actually doing once we get Calico installed and up and running. Okay, so back in our terminal, we saw that the Cubelet up here was giving us some errors. We don't have Calico up and running. We saw that we have some CNI executables here, but we don't have Calico installed. And if you remember, I commented out that command a little bit earlier. And we can go ahead and run that command here on the server to actually install Calico. But before I do that, I want to we're not going to go super deep into IP tables, but I just want to show some metrics here so folks can actually see that we're demonstrating that IP tables is in fact being mutated by these various parts of our system. So I have this alias called iptables list all. Did that not work? Let me add this really quick. I thought that alias would have worked. So let's go back, grep for alias, copy this line, go back in our terminal, close out of there, and let's see what we have now. Yeah, iptables list all. Okay, so we can do an iptables list all, and this is going to show us every iptable rule we have. And the way iptables works is you have different tables that do different things. I'm not an iptables expert. I don't ever want to be an iptables expert. Every time I've messed with iptables, it's been a bad day. But hopefully today is going to be our first good day that we're playing with iptables. Anyway, if you come in here, you can actually look. It's called iptables because it sort of outputs in this like sort of Unix parlance of a table here. And as we go through, we can actually see that we see a lot of Kubernetes bits in here. For instance, we have this kube forward rule. And if we scroll down, we actually see Docker down here. We can come down here and we can see there's some Kubernetes firewall rules. And then if we keep going, we'll actually see that we have kube system DNS up and running, and we have rules here. And so what this is doing is this is allowing various bits of our computer to talk to other various bits of our computer over like traditional networking. That's what iptables does. And we use this a lot in the container world as we start to, sorry, Tom just dropped a message, I'll read it in a second. We use this a lot in the container world as we start trying to govern and control which containers can talk to other containers. Regardless of if those containers are running on the same host or in different hosts, we can actually come to this level of the system, the iptables level of the system, which is pretty low on the scale of things, and actually turn bits on and off that only allow various parts of our system to communicate with each other. And if we keep scrolling, you can see that we have node ports, and we have like more Kubernetes services, and then somewhere in here there's kube proxy rules. I don't know if I'll be able to find them off the top of my head, so let's do a grep. So let's do our iptables list all command grep. We'll do -i for kube proxy. Okay, so now, oh, we got everything out of there. Okay. That's not going to be helpful. Anyway, I did see some kube proxy stuff in here earlier. If folks want to go in and look through iptables rules and actually try to make sense of which every individual rule is doing, feel free, have fun. I'm more concerned that there's really, really great engineers at companies like Tigera who brought us Calico that have gone through and pulled us up above all this, so we don't necessarily have to get involved with what's going on behind the scenes here. So thanks again for doing all this for us. So one more thing I wanted to point out before we install Calico is that we do an if config. You'll actually see that we have a network interface defined here on the system for Docker, which is pretty cool. If we didn't have Docker installed, we wouldn't have this network interface. And this is going to be relevant as we start looking at how different iptables rules are interacting with different devices moving forward. So as you're debugging your system for CNI, these are things to keep in mind, and you can actually go and keep an eye on some of these things as you make rules later. And see how they trickle downstream. So let's install Calico. So how we do that is, let's go back to our shell script here, and let's copy this command that I commented out earlier. So this is designed to be ran on the server. You could run a similar command here on your local file system, but we're going to actually run this directly on our server. And I'm trying to think, because it takes Calico a few minutes to spin up. I think we probably want to run, I'm trying to think. No, we're going to wait and run this because we can actually watch different parts of Calico be created real time. So we're actually going to look at the YAML first and then run it and not do it concurrently. So how we're going to look at the YAML is I'm going to create a whole new tab. I'm going to zoom in and come here. And I'm going to, instead of doing a kubectl apply, we're going to do a wget. Oh, I didn't do that right. Didn't backspace far enough. A wget, and then we'll get rid of all the stuff at the end too. So we just want to do a wget on our YAML, and we can actually see, oh, we don't have wget. Let's do curl. Moved permanently. Is this not wanting to resolve? There we go. We'll just look at our YAML here. That's fine. So we have a config map that resides in the kube system namespace. And I guess before I go too much deeper into looking at what actual resources were created here, this is the Calico command we use in Kubernetes. And if you actually go into the Calico documentation, it says how to install Calico. Let's go ahead and pull that up. You can see there's a couple of different ways. Project Calico. Introduction. Is there an install anywhere here? I haven't actually looked at this in a while. Oh yeah, SSL redirect. Thank you for pointing that out. Yeah, no, I know SSL and -l follows redirects. I was just like being lazy and in the moment. Okay, so getting started. Calico with Kubernetes. Is there install? Here we go. So install Calico with the following command. This isn't what I looked at earlier, so I wonder... No, we're going to go through that a little bit later. Anyway, there's different ways you can install Calico, and this is relevant when we get into Calico Cuddle later, where Calico can either use the Kubernetes etcd server as a data store, or it can use its own etcd server as a data store. In this case, we're doing the Calico installation where Calico runs an independent etcd data store, and that's how it's going to store valuable information that we can poke at with a command line tool called Calico Cuddle a little bit further downstream. Okay, so there's our 301 again. And let's pull up this YAML and see what we got going on here. So when you install Calico, you get a config map in the kube system namespace. The folks at the Calico project have done a great job commenting this, so I'm not going to go through and actually read this line by line, but if you actually want to learn about a lot with what's going on here, the documentation inline here is fantastic. Configure the Calico backend, and then it says the CNI network configuration to install on each node. So this is cool because this is actually a snippet of JSON that we're going to be able to find on our node a little bit later. And if we come down here, we have this daemon set, which this is the component. Let's see what Eric says. If you expand the installation on the left, you can see different options to install Calico. Oh, okay, so he was talking here in the docs. Installation, introduction. Okay, so yeah, here are all the different ways to install Calico. This was what I was trying to get to earlier. So this is just the quick start for Calico and Kubernetes. Thanks for the pointer, Eric. Anyway, this daemon set is the piece that's actually going to come through and configure Calico and configure the host system behind the scenes for getting CNI up and running and actually dropping off the Calico binaries. We already need them and configuring the Cubelet to use Calico as its CNI plugin. So we can demonstrate this. A really quick check is, if we remember, earlier I did a cat of etc systemd system Cubelet star. This directory here, CNI configure etc CNI net.d, if we actually try to let's try to list anything in there, you'll notice we get this no such file or directory. So we're going to sort of use this as our proof here to show what the work the daemon set is actually doing on the node behind the scenes. Jason says, apologies if already answered, but what are the main diffs between Weave and Calico, and which is better? See, Jason, this is a great question, because it's questions like that inspired this whole mini-series. You're not the only one who's wondering that, and we're hoping by going through and teaching folks about CNI and exploring each one of the CNI implementations and plugins, we can sort of gain some pros and cons of each one and understand the differences and why some might make sense in certain situations over others. In this case, we're doing Calico on AWS using a Qbert cluster. Great question, Jason. Okay, so the daemon set is not run yet, and we cannot access this directory because it does not exist. So bear that in mind as we go through the YAML here. We can assume that this YAML is going to go ahead and take care of that for us. So the daemon set will run on both the master and the node as well. And then coming through, we have a service that allows us to get to our Calico etcd. Remember earlier I mentioned that we're running Calico with its own etcd. This is just the service that's going to allow us to get into etcd a little bit later, which will be relevant when we get Calico Cuddle up and running. And we have the Calico Node, which is another snippet of software. It says, this manifest installs the Calico Node container as well as the Calico CNI plugins and network config on each master and worker node. Okay, so this is the daemon set that I was talking about earlier. I'm wondering how that one is different than this daemon set. It says this one installs the Calico etcd on the kube master. Okay, so I misspoke earlier. I saw a daemon set and just assumed it was the Calico one. But this daemon set actually installs etcd, and this is the one down here that is actually going to do everything that we just looked at earlier, and it's going to create that directory that does not exist yet. So I don't want to spend too much time here because we're already almost an hour in, but you can see that the configuration here is already built in for us, and it looks like there's even this install CNI.shell script that's going to be ran, and then we do some things with different volumes. And I would be willing to wager there's components of this daemon set that are going to be dependent on the etcd server up above. And last but not least, we have a Calico policy controller. Okay, so this is relevant because we have CNI that's going to build our pod network for us, and that's going to allow different pods in Kubernetes to do different things with each other. And then we have this whole concept of network policy in Kubernetes as well. So this is a network policy controller, meaning that as we mutate network policy resources in Kubernetes, there's a controller that's going to run and reconcile those policy rules and make that actually work. In the case of Calico, how it's going to do that is by mutating IP tables and route I think the route table even. Let's go look at the route table really quick. Behind the scenes and bringing those network policy rules to life. So to look at our route table, we just typed route. Okay, nothing exciting going on there. Okay, but good to know for later. I haven't actually looked at the route table before and after Calico in a while. So without further ado, I know I've said this like 3 times already, let's install Calico. So let's grab this and go here and paste. So let's run that. And you can see it created our config map. There's our etcd daemon set, created a service, our Calico Node daemon set, our policy controller, and then I kind of breezed past the RBAC stuff here at the end. But we did get a service for our etcd, which is going to be relevant. But yeah, if you want to go through and look at the RBAC rules, you're more than welcome. And again, big thank you to the folks at the Calico project for actually creating the RBAC rules for us. And real quick, while that installs, I'm going to take a quick breather, see if folks have questions. And my knee just locked up, so I got to like stretch my knee out for a second. And I'm going to grab some Diet Coke. See if I can't like, that feels better. Okay. Okay, so the CNI plugin is created. Let's go ahead and see what's going on in Kubernetes behind the scenes. So if we do kgit po, namespace kube system, not found. We want to do it on our local here. So let's clear that and do kgit po, namespace kube system over here. You can see now we're bringing up pods here in the kube system namespace. Stefan says you should probably get used to using IPR instead of Rouch, which has been deprecated for a long time and should disappear soon. Thank you, Stefan. I noticed that. I'm just super old school. I think ifconfig is also deprecated. I think we should be using IP adder A or something. I don't know. I'm such an old school Linux person. Like, I still check etc init.d for skeleton files. I don't have any shame. I love Linux, old Linux. But actually, in the README here, I put a bunch of debugging snippets here. If the one you suggested is not in here, we should totally add it. But here are some other handy things for looking at the route table and actually seeing which TCP ports are doing what on your system. This command here, this is actually probably in the wrong spot. This isn't really showing the route table, but I do want to call this command out. I dated this guy like 3 years ago, and he was a sysadmin, and this is like the only good thing that I got out of trying to date this dude, bro, was this netstat tolpin command, which I still use all the time to this day, and I always remember it because tolpin rhymes with Tolkien, like J.R.R. Tolkien. But you can do a netstat tolpin on a Linux server, and you actually can see which pieces of software are listening on which port. This is super handy if you're ever debugging anything. This is like the one command that you want. And you can actually see the kube controller and actually see it's running here on 2380. We have kube proxy on 10251 and the kube scheduler on 2379. So that's handy as well. And George, our friend from Canonical, who's now at Heptio, says IP is the command to use. IP adder show, for example. Thank you, George, and thank you, Canonical, for the operating system we're using today. And for changing up all of my commands on me so that I have to run new commands and relearn how to use Linux. Okay, so let's do our kgit po again and see what's going on over here in the kube system namespace. So a moment ago, the policy controller, which remember this is the controller that's going to enforce Kubernetes network policy, it was still creating, and it looks like we had Node and we had etcd up and running. So if we run this again, not netstat tulpen, but kget po namespace cube system. Hope the sysadmin dude never watches this video. He's still a good buddy of mine, so I kind of hope he does. He would laugh hysterically if he saw that. Anyway, IPCA is like ifconfig, button color. Ooh, what? Okay, I want to try this now. Button color, and it's super useful with Calico and hundreds of interfaces. What? This is awesome. IP minus CA. Oh, that's beautiful. Okay, I really like this command. This is really handy because you can see the different interfaces and what we have going on here. Thank you for the share there, Stefan. Yasin. Okay, so let's scroll over here, and we now see that we have everything over here on the right is running, and looks happy. Sorry, I'm reading and trying to code at the same time, so my thoughts keep going back and forth. The new IP is generally lack of docs, I feel. Okay, I haven't actually looked into IP that much, but I'm going to let you guys talk about the different IP commands and look at what the daemon set is doing behind the scenes. So if you remember, we had our list command in our batch history, so I can run this command again, and poof, we now have this wonderful directory that's been created, and we have some configuration files in here. So if we actually go into etc CNI net.d, we can cat out this calico.conf. Looks like there's some token information in here. Nobody steal my token. It won't really matter anyway, because by the time you're watching this, my Kubernetes cluster will probably be offline. And you can see our etcd endpoints, and in fact verify that etcd is listening on port 6666, which is going to be helpful later. We were looking at that earlier, and we weren't sure which port it was listening on. So that's good to know. And if we come back here, and we can journal cuddle fu Qbert, we can actually see that we've got some stuff going on, and we're not getting those CNI errors anymore. And I bet if we go back here to our kget nodes, aha, we now have 2 ready nodes. And I bet if we kget pods, we actually see that, in fact, our Nginx server is running. And I bet I can do a k port forward, the name of our pod, and then let's just do 80. Permission denied. No, let me try that again. Sudo kubectl port forward, name of our pod, 80 to 80. Bam, and if we go to localhost, let's see. Localhost 80. Poof, welcome to Nginx. Nginx ready in Kubernetes with Calico as our CNI provider. Let's go look and see what's going on now with IP tables. So if we come back here, we can do our IP tables list all command, and let's see what's going on in here. If you notice, there's this commentary here that says Cali and then has some sort of tag here. I thought that was funny because my partner's name is Cali, so all day today I've been talking about Cali, and it's made me think of Cali. Anyway, and I'm going to California, so it's just lots of Calis everywhere. So anyway, if we come in, we can do Cali, and we can do a word count on that. So let's grep for Cali, and do a pipe that to word count lines. Ooh, did that not work? Why is that not working? IP tables, list all, pipe to grep for Cali. I almost typed her name, their name. Okay, anyway, I was going to try to show you how many times the word Cali appeared so that we could actually see that IP tables were being created when we created some network policy later. But for whatever reason, my grep isn't wanting to work, probably because of the way I have my alias set up. So we can actually just maybe do a word count on this whole output. 8. Okay, so there's 8 commands there. So it's just coming out one line at a time. Okay, that's super annoying. So the grep is matching because Cali exists in every one of our table outputs. It's not actually doing a grep on each line within those table outputs. Anyway, that's going to be a bit of a bummer. Lisiano says, have you tried redirecting standard error, standard out before the grep? No, if you want to throw a command in there you think would work, Elysiano, I'm happy to run it. Feel free to just drop it in and I'll run it. Anyway, let's go back and look at, so actually what do we want to look at? Okay, so the Cubelet is happy. We're routing, port forwarding is working. We know that our configuration is working. We know Calico is working. Let's pull up the Calico logs and let's run the Calico command line plugin tool here really quick so we can see what actually the Calico service and the Calico controllers are doing behind the scene. Yeah, folks are just saying the alias doesn't work. So you know what I bet I can do? Let's do this. I'm going to just hack this up really quick. So Emacs, we'll put it in home. We'll call it iptl .sh. And we'll do ben bash. And I bet I'm going to totally be hacky here. Come back to our README. Let's grab this. Go back to Emacs. And then I bet we can sh, IP table sh, pipe to grep for Cali, and then pipe to word count, poof, 131. Okay, good call. Thanks for mentioning that alias does not go to standard out, or does not work for grep like that. So let's go and move this into our path. So let's try to think how I want to do this. We'll move home / IP table list.sh to user local ben. We'll just call it iptl. Works for me. Chmod plus x user local ben iptl. Perfect. Okay, so now we have our IP tables list command with all of the 8 different types of tables we can use. And we can pipe that to grep, iptl, grep for Cali, and grep to word count, 131. This is going to be handy. So here, we can go ahead and kill this port forward. Let's grab logs on our Calico controller and see what's going on here. So kgetpo, namespace, cube system, and let's do Calico Node, klogs, Calico Node, namespace, cube system, -f. We need to pick a container, so let's do the Calico Node. So -c Calico Node, bam. So this is the Calico Node daemon set pod that we're watching, and we can actually see it. It's running, and it looks like it's doing some stuff behind the scenes here. I think it just kind of runs in this cycle where it'll just run this over and over again. And it looks like if we read it, it says applying data plane updates. And it's asking to resync with data plane, and it says IP sets, resyncing data plane, family inet. So this is Calico's way of going through and just refreshing the data plane behind the scenes for us, and I think that's where we're seeing a lot of the IP tables mutations that we're going to get to a little bit later. So we have our logs pulled up, and I want to now talk about Kubernetes network policy, now that you sort of see where the rubber meets the road holistically for Calico, how the Cubelet is interfacing with the Calico plugin, which is, of course, here in opt CNI ben. We have Calico now, and if we run it, of course, it looks like all the other CNI plugins we had before as well. So this is the actual plugin where it's running on our file system that the Cubelet will be execing. I bet if we did an LSOF on it, we could see that it's being opened and closed quite often. Anyway, let's go through and look at this lovely documentation here. So where is it at? Network policies and isolation. We'll talk about that a little bit more. Configuring Calico Cuddle. No, because there's this one piece of documentation here. Let me close some of this stuff. I don't know how all of this got open. That I wanted to pull up. That's like a really great tutorial on doing some Kubernetes network policy with Calico. I think it's simple policy demo. Yes, this is it. Okay. This is probably the best demo I've ever done in Kubernetes. Every command worked great, and it totally made sense to me. So whoever wrote this, pat yourself on the back. This is a really great demo, and we're going to fly through this, and hopefully it's going to make sense to a lot of people. So what we want to do is we want to first create a namespace for this little demo we're going to do to show how Kubernetes network policy works, which is kubectl create new namespace called policy demo. So we're going to do that here on the right. Actually, let's do a whole new tab. We're going to be flying in between tabs, so try to stay caught up with me here. Kubectl create namespace policy demo. And it says run the pods. And if you look here, we have a kubectl run namespace policy demo nginx replicas equal to 2 -- image nginx. So this is just like the fancier version of my Qbert will run nginx command, which I think is probably why I liked this demo so much, is because it's doing things the way that I'm used to seeing them. Anyway, we run this command, and it says, okay, we have a deployment in apps called nginx created. Now remind yourself, we have a deployment in the default namespace called nginx, and we have one in the policy demo namespace also called nginx. And here we want to create the service, so this is going to create a service, and it's going to expose port 80 for the pods we just created in the nginx deployment. So it says service nginx exposed, which if you guys aren't running Qbert will expose, it's a great command and helps you expose things quite frequently. That would have been really helpful to run on the traffic episode I did a few weeks ago. And it says ensure the service is accessible. So before, I ensured that nginx was running by doing a port forward, then actually sending an HTTP request up to the server. In this case, it looks like they're going to do a wget on a pod running in the same namespace. So how they do that is they do a Qbert run namespace policy demo, and it's going to run a busybox container, and it's going to open up a TTY running shell for us, so we'll be able to actually navigate that container. So Qbert run command, paste that, and then we should be live inside of the container. If you don't see a prompt, try pressing enter. And then if we go and copy and paste this next command, we should see some output from nginx. So it's really important what's going on here. We have two containers running on our host system. In fact, if we, I don't know if we'll be able to see it here, but we can do a docker ps and actually grep for nginx. We don't have it here, but if we actually did a docker ps running on our node, we would be able to see that we have two nginx containers running. We can do that if folks want to see that a little bit later. And when we do this wget, we're actually using the DNS service in Kubernetes to look up nginx, which is just the name of the deployment we're trying to access. And we can do a wget there, and it's going to hit those pods. Tom says you're running a slightly older version of Calico, so it might be worth selecting v2.3 from the version drop down in the top right. Okay, I didn't realize I was running an older version of Calico. To be honest, I didn't even check it out before the episode, but thanks for pointing that out, Tom. Let's see, Abdebnor says can combine both commands by specifying the -- expose on the first one. Totally. Thanks for the tip there. I think we just wanted to do in two different commands to kind of show folks the two different steps that we were doing. How do I whitelist the health check request from Cubelet? Whoa, a lot of chats coming in hot. I can't send you a direct link to the docs as chat won't allow it. Tom, it's okay. I can. This worked for me earlier, so I think we're good. But if I need to switch over, I totally will. But this documentation worked. I just ran through it a couple hours ago, so I think we're going to be okay. So anyway, using Kubernetes DNS to look up nginx, and we send a actually it's back here. We send our HTTP request, and you see that we actually get the HTML back that says, thank you for using nginx, which is the same HTML we looked at earlier when I just ran nginx just to ensure that Calico was in fact up and running, the kubelet was happy, and we were able to schedule work on our cluster. So what's happening here is we have one pod and one container in one pod that's able to do a DNS lookup against the Kubernetes DNS service, and then actually not only find the other container it needs to get to, but actually make the traversal across the network from one container through a pod back down to the host system, and then hit the route table and actually go and find where this other container is running. And it did all that sort of magically for us. So that's what the CNI bits are doing, is they're managing this complex intricacy. In this case, we only have one node. Like if I pull up Amazon here, we can actually see that that's all happening on the same node. But if we were running a very large Kubernetes cluster, there's going to be a lot of nodes that need to be configured, and that's where a tool like Calico really starts to shine, is because it's going to be handling all of this complex configuration across nodes and being able to tell us like how and when to route to which container and how to get there. So a lot of networking fun behind the scenes, and for users like me, I don't really have to care about it because it just magically works, and I love it. So if you see here, we can jump on our node, and we'll actually go and validate that this is in fact what's going on. So we'll come here to this other tab I have open. We'll SSH Ubuntu at this IP address. We'll sudo up, and we'll do a docker ps. And let's grep for nginx, grep nginx. And you can see here, We've got a couple of pods containers and a couple of regular containers running. Remember, we have 2 replicas for the Calico demo Nginx. We have 1 Nginx container for the Nginx deployment I created in the default namespace, and we have some of these /pods here as well. And you can see the Kubernetes pod parlance over here on the right, and these are the containers that are running, and they're able to network to each other on the same host. Again, this would be a little bit more complex if we were running on a larger cluster, as we would have to hit the AWS network behind the scenes and actually traverse that network as well. So going back to our demo here, we now are able to communicate between the 2 pods. So what this is going to do is this is going to give us a really quick demonstration of network policy in Kubernetes. And if you want to pull up the documentation on this, there's a really great link here that's network policy and isolation. So the first thing our demo tells us to do is it says enable isolation. So how we do that is we create this new network policy. I thought we had to annotate something. Maybe I am running the wrong annotate. Yeah, the documentation I went through earlier had me sending an annotation. Let me see if I can't change this. So let's see what the chat said here. I actually am going to change this. So Tom says you're running a slightly older version of Calico. Might be worth selecting v2.3 from the version drop down in the top right. So how do where is that at? Version nightly, v2.3, project Calico documentation, introduction, let's see, reference maybe, usage, Calico. I want to go back to the Kubernetes documentation. Getting started. Kubernetes tutorials, simple policy demo. Aha, okay, good. You were right, Tom. I don't know how I got onto the different version earlier, but this is what we're looking for here. So up until this point, everything we've done is still the same, and now we're just going to do this annotate command instead of what the more recent documentation had us doing earlier. So this is how we're going to turn on isolation in this namespace. And if you go and you look at what isolation in a namespace means in Kubernetes, you can actually see that we have isolated and non-isolated pods. It says by default, pods are non-isolated, meaning they accept traffic from any source. So the second we turn on isolation, we sort of flip that logic around, and then network policy becomes relevant, meaning that we can start to govern which pods can talk to other pods, and we can put network policy rules in place that allow us to control at the networking level how these pods communicate. And of course, that's why the Calico controller, the Calico policy controller is relevant, is because it's actually going to be reading these records in our network policy in that same namespace and reconciling that using tools like IP tables to actually make that happen for us behind the scenes. So if we go here, we can run our annotate command. Again, thank you, Tom. That was very helpful. And let's see, that's our node. This is where we're doing our demo. Let's exit out of that pod. Let's run our annotate command, and it says namespace policy annotated. And all we did is we added the simple annotation here, network policy ingress equals isolation, and we said default deny, meaning that we've now enabled isolation, and that by default traffic will be denied instead of the other way around, how Kubernetes ships with default allow. So now it says when using the Kubernetes API store, we want to do a kubectl create, and we're going to create a new network policy record. So let's go ahead and do this. New network policy record. Pod selector. Is pod selector not defined in here? Yeah. Let's see if we can find a better example. Let's do 3.0 maybe. And getting started, Kubernetes, tutorials, simple policy demo. Nope. But we can grab that. And I bet if we go and we edit our command, let's do this in my text editor here, we can actually get a working command up and running. So here is our text editor, and we're just going to edit this. We'll just do a new file. We'll call it edit. It's just text. And let's go back here. We'll grab this, paste it, and then we're going to use that to rebuild our new one, which if we go back to our 2.3 version of Calico documentation here, we can actually fix this really quick. So for pod selector, we want to grab match labels, put that here, make sure our YAML is correct. And then this command here should work. Although we don't have anything for our pod selector, so I'm wondering what that's going to do later. But let's just go ahead and run this and see what happens. OK, network policy extensions default deny created. Talking with Alex yesterday, the way that this works is if you create any network policy, the sort of behavior of how network policies act is sort of flipped on its head by default. I think, and Alex, keep me honest here, I want to make sure I say this right. I think it's default allow until you create some sort of network policy rule, and then it flips that around and becomes default deny. So by sort of creating this empty network policy, we now have default deny, so we should not be able to route from pod to pod by default. So let's go ahead and make sure that's actually what the tutorial is telling us to do here. It says test isolation. So we can run this kubectl run command again here. 1 second, really quick. I'm gonna jump back over to my face. I don't want to open up my text messages here. I'm live on TGIK. Okay, close those and get those out of the way. Go back to my screen. Okay, cool. So network policy default deny, and now we can run our kubectl run command. There's that. And let's go back to our documentation. And it says waiting for pod. That's just the output. We don't need to see that. And now we can get this wget command again and actually ensure that our network policy isolation is working as expected. So we run our wget with a timeout of 5 seconds, and I bet 5 seconds from now we're going to get a timeout. 2, 3, 4, 4-ish. Wget download timed out. So Alex says the namespace annotation was required back a year ago when Kubernetes network policy was still in beta. Calico version 2.3 is now from that era. Calico 3.1 is the latest now. And that explains why the documentation no longer required us to do an annotation. OK, thanks for the history lesson there, Alex. So let's go back here. So we've now proven that our network isolation of default deny is working just by creating an empty network policy rule. And now we can go ahead and open up our network policy rule using the Calico policy controller, which do we have logs on that yet? Let's do logs as we do this side by side, because that would be pretty cool to watch. So let's see. We have kgetpo. Namespace cube system, cube-system, and we're already at 2:30, so I have a feeling that I'm going to be able to get this network policy stuff done, and then we're going to be done, so we're probably not even going to get to Calico Cuddle today. I'm sorry this is taking so long. There's just a lot of fun stuff happening in Calico for us to talk about. Okay, so we want to get logs for the policy controller. So we can see this. There's the policy controller, so klogs, paste the name of the pod, namespace cube system, -f. And cool. All right, so we should be able to create our new policy rule and actually watch. Let me exit out of this and actually watch the policy controller take some action here side by side, which will be pretty cool. So coming back here, we can run this command, kubectl create -f. Nope, we want my terminal. There we go. And if we run that, hey, look, it says it's handle added new policy. And if we go back into our, here, let me SSH back into our server here, sudo bash, and let's run our iptl command, grep for Cali. I love saying that. iptl grep for Cali, pipe to word count, -l, 131. So we haven't actually changed any IP tables rules yet. Interesting. But if we come in here now, we can now run a new busybox pod. Namespace from server deployments apps already exists. Oh, did I skip ahead in the documentation? Let's see what it says. We should now access this service in the access pod. Kubectl will run. Why did this not work? That looks like it should work. Let's see what the output is saying here. Error from server already exists. Deployment apps access already exists. What namespace is this in? It is in namespace policy demo. Oh. Oh, duh. Because I'm running this, I'll keep this one sudoed up. It's because I'm running this on that one. There we go. Let's run this on my local. Kubectl run namespace policy demo. K get PO, namespace, policy, demo. And we want to kill this pod. K delete PO, bam, namespace, policy, demo. And now let's run this again. Actually, if there's a deployment, we'll just see what this one does. If there's a deployment, yeah, we got to delete the deployment. K get deploy, namespace, policy, demo. K delete deploy, access, namespace, policy, demo, and then run our run command again. Okay, so now if we do our wget, we can see oh, what happened here? Session ended, resume using Qbert attach /it command. Why did that end? That's weird. K get PO. I don't know why that's not running. Policy demo. What is going on here? It's terminating. Is our deployment still there? K get deploy namespace policy demo. Nginx. Okay, that's still there. I have no idea why that's terminating. Very weird. Let's wait and run this after those pods terminate and see what happens. Anyway, effectively the demo is going to demonstrate that by enabling this network policy rule, we were able to define the match labels run equal to access, and we were then able to actually match that to the Nginx pod we created earlier, and the Calico policy controller would then begin to allow traffic from this pod we're trying to run unsuccessfully and do a wget coming back into Calico. So I'm going to try this one more time, and then I think we'll do a high-level overview and wrap up for the day, and maybe we can do another episode on Calico Cuddle or use it in another episode as we actually look at the Calico Cuddle network policy and how that is slightly different from the network policy we see here. If you go back and you look in like the history of the Kubernetes GitHub issue tracker, you can actually see that this network policy object is a slight derivative of the Calico network policy object, which is how the Calico tooling actually goes and enforces network policy, allowing and governing traffic from pod to pod. So let's try this again and see if Kubernetes has finally decided to catch up. And there's our deployment there. So I don't know. I guess I deleted our access and then that didn't recreate. I don't know. I'm going too fast and it's getting late on Friday. I'm starting to lose it. Okay, so let's try this one more time. Close this. Qbert run. Now we're in our pod. Good. And let's make sure that we can actually communicate over HTTP. Okay, poof. That was much simpler. I don't know what I did. I probably just deleted the access deployment and like forgot about it, or I don't know. My head's got Cheetos in it right now. Anyway, we were able to validate that the network policy is working. We turned default deny on. We communicated from one pod to the other, or tried to, and it timed out, meaning that the policy controller was in fact enforcing that policy. We opened up the policy, and if we actually look at the pod, get PO -namespace policy demo. If we actually look at the pod, we'll be able to see the labels that we're matching on. K get PO namespace policy demo. We can actually look at this PO, and we should be able to see the labels there. Oh, YAML. And we scroll up to the top, and here under labels, yes, we have run Nginx and pod template and match labels. Where are you at? Anyway, so yeah, that's how network policy works in Kubernetes. That's how Calico is going to enforce network policy, and how Calico is going to be interacting with our host system to enforce the different networking components here. So bear all this in mind as you're looking at CNI providers and trying to understand which one is right for you. Calico is definitely, from this example anyway, it's demonstrated that it's going to be it has what we are looking for when we start getting into complex network routing with large numbers of servers. Because Calico runs as a daemon set and has its own data store, it's able to do some pretty cool things as we actually start to scale out our cluster in clouds like Amazon. Calico ships with its own etcd if you install it that way, or optionally can ship with running against the Kubernetes etcd server as well. Pros and cons to each one of those. We looked at network policy in Kubernetes. We learned about network isolation and how you can turn that on. We learned about how network policy behaves, how it starts out as default deny, and then you can give it a network policy rule with a label, and then you can see that the Calico controller will actually go and enforce that network policy for you. So now we have some pretty flexible tools as systems administrators to start locking down our networks and locking down our Kubernetes clusters. So not only can we use different parts of Kubernetes, such as namespaces and other logical boundaries, but now we can actually just downright block traffic based on arbitrary labels in our deployments in our pods using network policy. So that's a pretty powerful construct for systems administrators, especially for security-minded systems administrators, being able to control the complexities of your system with tools like IP tables and whatever implementation you happen to be running with your CNI plugin, coming up layers above that and saying, no, we can just define this very simple network policy object and actually have a controller go and reconcile that for us behind the scenes. So again, this is the age-old lesson we always see in Kubernetes. You declare something and then some sort of controller goes and actually makes it so. So anyway, I'm going to cut back to my face here. I'm going to get out of here. I got a big adventure planned this weekend. It's been great hanging out with folks. Thank you so much for joining. I'm going to spend the last minute or two here if folks want to start saying goodbye, getting stuff cleared up, shutting my cluster down, and seeing if anybody has any questions or anything they would like for us to follow up on, explaining maybe why we picked Calico or what Calico is doing behind the scenes, or how Kubernetes network policy works, or how the Cubelet is interfacing with the actual Calico plugin. Feel free to let me know. And again, it's been a great episode, so thanks everybody for joining, and I'm going to start to tear stuff down while you all say goodbye and go enjoy your Friday afternoons or Saturday mornings, wherever you happen to be in the world. We want to exit out of that, get off of our node, clear that. Let's go and we're going to shut down this Kubernetes cluster. Go source github.com/heptio/ what do we want? TGIK. Bam. Let's go into episodes and 45. So change directory into 045. Yeah, thanks for joining, everyone. I'm seeing thank yous coming in now. It's always at the end of the episode, so I try to give people a few minutes of a heads up so they can say goodbye while we're still live on the air. Yeah, it's been great hanging with everyone. Liz, good to see you. You're very welcome. Yeah, I'm going to continue shutting down my cluster while other folks say goodbye or if they have questions. Questions are always a great one. Okay, so what do we want to do here? We want to do kubecorn delete TGIK Calico, what is the name of this thing? Let's tree it again. Kubecorn delete TGIK Calico cluster dash capital S kubecorn. Okay, so that's tearing down our cluster in Amazon. Let's see what folks are saying. Folks are saying thank you. Tom says thanks, Kris. Great overview. Simon says thanks. Have a great weekend. Injin, thanks, Kris. We'll watch your arm this time. I definitely will. I'll be very careful this weekend. Don't worry about me. Natter says interested in the security story of the CNI plugins, the etcd store, for example. Anyway, thanks as ever. Good night. Yeah, we can probably poke a little bit more about what Calico is doing with etcd behind the scenes. Getting Calico Cuddle up and running and communicating with etcd is a good way of seeing what we're actually storing in there and how Calico is actually running behind the scenes. But there's a whole layer of tooling that goes beyond the scope of network policy that, like the folks at the Calico project are working on that, sort of spans this community-driven spec. So you can go in and actually do even more with the Calico plugin than just a simple Kubernetes CNI plugin. So that's pretty cool. And again, I wanted to give a big shout out to our friends at Tigera. It's always great to work with you guys. You helped us out a lot today when I was getting Calico up and running, and I think you're pretty much responsible for keeping this project up and running. So thanks for all you do in open source. We appreciate it. And I know all of our folks running Kubernetes on Amazon with the Calico CNI plugin that probably gets bypassed quite often as it's just a one-liner in our install scripts. are probably super grateful that we don't have to go in and deal with, watching the route table, storing meta information, handing out IP addresses, mutating IP tables, and doing all of this lower level networking component configuration that this tool does. So thanks to you guys. We really appreciate it. And I am out of here. So we'll see everyone next week. I think I might be back next week. Unsure. It could be Joe. But either way, it was good to see you all, and we'll see you next week.